It won't absorb the particular data. Absorb the data points, whatever the data points are crossing the origin only. So okay, so that is here, that is also here only. That means what is the role mean? It will shift that your activation function. The bias value is used to shift the activation function. How to trigger the activation function? Whether the trigger should be either left hand side we have to trigger, or activate we have to trigger the right hand side. How the main concept of the C in the bias values to trigger the or to shift the activation function either left or right. So in another one angle, suppose you imagine that all your x inputs are 0, your x1 to xn, all the values are 0. Then what will be the output of the particular one neuron? So particular after the summation function. So definitely, because we are adding, all are multiplying. So definitely x1 to xn 0 means it value also 0. So to avoid that concept or to avoid that situation also, we are giving one constant value. That constant normally we called as a bias. The neural network, that is a bias. So bias will be giving act as a shifting function. Used to shift the activation function either left hand side or right hand side. Okay. Then that is a bias. What is the use for bias? Another one thing is what is the use of weight? Normally we are giving the input. Okay, input. What is the meaning of here input? X1 to xn we are giving that input. So why input in the run? It is a features. Input is nothing but it is a feature. For example, my problem is I am saying that like whether it is a car or whether it is a dog, or I want to do normally everybody we are the image classification deep learning means they may say one example dog and cats. Okay. You are giving that input the dog as well as the cat. So you are giving all the features about the dog and the cat. So finally your model will predict, your model will distinguish that. So this object is cat or this object is dog. So that is output. Okay. So you are giving the input image. Finally, it will say that whatever you are giving the input image, this goes to the particular one category, either dog or cat or sheep, or go to whatever it may be. So here, so you are giving the input features. Okay. Among the features, some of the features only giving more weightage to get the particular outputs. For example, I want to differentiate whether the particular image is dog or cat. So here you are giving the color, is the color about the particular object is there, background might be there, or your face. So many features are there about the particular one image, particular object. Okay. So here, which one give the more impact to differentiate whether it is a dog or cat? Shape. You may assume that shape is the one feature, color is the one feature. We cannot treat both the feature in an equal manner. Is correct? We want to differentiate, identify that this object belongs to dog or this object belongs to cat, means we got to need some of the features, we got to give more weightage. But that features only going to distinguish or differentiate this object belongs to particular object. Suppose I want to identify all the students. Okay, I am giving all the students a mark is there. So I want to differentiate which he is a student, and I want to know that who is the extraordinary student, who is an excellent student. So here mark, we are giving the mark is the input. Along with that mark, we got to give some weightage. Those who maybe attendance is more, or those who are going above 90 is there. Some criteria will be there. So that criteria is the mainly used for categorizing or classifying the objects. So for that only weight is more important for that neural network concept. This is the reason behind that we are using weight, because we got to differentiate, we got to distinguish, give the weightage about the particular feature. So whichever feature you are giving, you assign the more weightage value. For example, you are giving the shape and the color is there, we got to assign, because internally it is only assigning, because it is some the looping kind of processing is there. So suppose if we are not able to get to predict properly, means we got to give more weightage about the particular one attribute. So for that only, if you want to give the more weightage, mean it will predict properly. So that only we are using that weight for associated with all the input data. Okay. So another one is that, so first one, okay, up to, I hope that up to input data is there associated with the, so what is the input data here? The neurons will receive the input data, means all the features. So all the features are associated with weight that is given to that the particular neuron. So the neuron will process. That means it is just like a summation function only. It will sum all the things along with your threshold value. So then after that, before the output, we will do all your summed output. So in the output of all the data, it is a one value. So that value we got to give to your activation function. What is the input to the activation function? Your input data summed all the weightage, multiplied all with the weightage, then you added the bias value, you will get one value. So that value you are giving to the activation function. Here, what is the role of the activation function? That you will see that. So normally the activation function, it is a non-linear function. So what is the meaning of linear and the non-linear? So linear means it will go straight. It will go to that the straight one. Non-linear means it is not go to the straight only. Okay, that is a non-linear function. It is a single number. You know, already we know that all sum together, your input is a single number only. It will map with a single number with some range of value. Whatever I am getting the input the data, the activation function will map the value between the 0 to 1 or minus to 1 or 0 or 1 according to that. I will tell you the activation function role with the help of that. So it maps the input value to the range of value between the either, depends upon the function, depends upon the what type of activation function you are using. So normally in the neural network, it is our defined only. So depends on, we have to use either step function or we can use the sigmoid function or tangent function or a rectified linear unit function. So these are the so many functions are there. So these are the some of the important function we will use in that your activation function. Okay, what is a first one, step function means, so it will react based on the threshold value only. So step function is a threshold based activation function. In the input value is above or below the threshold, only the neuron is activated. So whatever you are setting that up to that threshold value, then only it will act. You see here I am giving the f of x. So it will react when it will gives the 1 till the 0. Your x of value 0 means there is no change is there. So I am setting the threshold value. Once it reaches the 0, then only you have to give the values 1. Okay. So till the 0 point, there is no step, there is no increment. So once we reach the threshold value, so then only above that threshold value, then only it will react. So otherwise it won't react. Okay. So that is the step function. Second one function is sigmoid function. So this is the sigmoid function. So most of the people normally we are using the sigmoid function. Another one is ReLU function. Okay. So here the mathematically what is f of x equal to 1 by 1 plus e power minus x. So this is the formula. So what is the use of it? It is smoothen the gradient. So gradient means we got to avoid the error kind of thing. So that is only, it will prevent the jumps in the output. It will not sudden jump should not be there. It should be the your output should be gradually it should go. It should not go sharpen up or sharpen down. We have to avoid. Your prediction should not go sharpen or your prediction result should not go down. That means that only we have to use the sigmoid function. Actually, the sigmoid function we have to activate your neuron. How your neuron is activated? You see, I'm telling some real simple example. According to what is the thing means, suppose your brain you are seeing that we are seeing that if you are seeing one small one lizard is going, okay, one lizard is going, how your reaction will be there? One small snake is crossing, how your reaction, how your brain. So both are small, some the animals, both are animal. So how your brain will react, what is activated, how your brain is activated, the same thing only. So it depends upon how your brain we are activating your neurons. So that activation is done with the help of this function only. So this is the another one function. So this is a tangent function or hyperbolic function. So this is the whatever your input, we are giving that this is a mathematical. So accordingly your output will predict. So whatever type of output you want, whatever type of output you have to get it from that particular neuron, accordingly we have to choose the activation function. It is simply just nothing, we are activating the neurons. Okay. So this is the one normally we will use. Most of your neural network concept, whether you are using convolutional neural or RNN, most of the application program we will use the ReLU. So ReLU is nothing but the rectified linear unit. Okay. So what is the logic? It is whatever you are giving that input, it will take the two values. It will compare with whether 0 and max. That means what is the meaning of f of x equal to max comma 0? So till 0 it won't react anything. Whatever your input is coming, till the minus it won't react. Once the value reached above 0, then only the function will react. So that means your activation function, whenever you are defining the activation means ReLU, till the value input value is 0, negative to 0, the function won't react anything. There is no activation. There's no activation from the outside. When it cross 0, then only it will give the output. So that only we are using the ReLU. So this is the things. Okay. So these are the 4 functions mostly we'll use in the neural network. So whenever now you are defining one neuron will associate with the input data along with the weight, along with the bias, then we got to define the activation function. So input data, then your associated weight along with the one bias value, all summed together given to the activation function. Depends upon the whatever you are using that activation function, accordingly it will map to the particular output. So this is the one neuron process up to this one. I hope up to this level you understand the concept. Okay. Next, why we are using here, it is a deep learning. Actually, the deep learning, the word, it is comes from the neural network. So neural network is our biology concept. While your computer, coming to our computer science, we can say it is a artificial neural network, ANN. We use the term artificial neural network. So artificially we are creating the one neural network. So your deep learning is based on the ANN, as artificial neural networks. Here for learning deep, we are learning the things deeply with the help of the layers. We are using n number of layers. Actually, here there is no feature extraction process. There is no feature engineering. There is no pre-processing. All are taken care by the your layers. So the layers only we are doing all the things. So it will deeply go, extreme level it will go to the extracting the features. For that only we are calling the term, it is a deep learning. So here in the already told you what is the difference between machine learning. Here there is no separate feature extraction process. The layer itself, it will do the things. But here one of the important problem in the neural network concept is it will give the overfitting whenever your data set is small data set. Morning class we discussed the what is the meaning of overfitting, what is the problem of underfitting. So whenever if you want to do prefer some neural network means first thing is your data should be some high level, more data set. Your samples or data should be more data, then only it is very good for optimal fitting. Otherwise it will give the some overfitting. So then your layers, how the input is input data, we are giving the input data and finally we are getting the output data. So internal one layer concept is there. Normally we call it as a hidden layers. We call it as a hidden layers. So how hidden layers only plays a major role in the neural network concept. So normally the neural network concept we can say it's a single layer perception. Another one is a multi-layer. Single layer means we are using only one layer. Single layer means input layer, output layer. There's no hidden layer. There's no hidden layer concept. Where we'll use whenever we are receiving the input, that will process, that will immediately it will propagate to the data here. And one more thing, input data, there's no processing. The role of input layers, the role of input neuron is, so whatever you are getting the data is just pass to the next level. There's no processing in the input layer. All the processing are internal layers, your hidden layers along with the output layer only. All the processing should happen. There's no processing in the internal layers, input layers. In the input layer role is just to bypass whatever we are getting the input. So and if we are seeing that single layer and perception layer, multi-layer concept means that we got to use with the help of two concepts. One is a linear separable problem. Another one is a non-linear separable problem. So single layer perception is good for the linear separable problem, whereas your multi-layer concept, multi-layer perception is good for the non-linear separable problem. Now I will tell you what is a linear separable problem and what is a non-linear separable problem. Okay, then we will see the back. So what is a linear separable and non-linear separable means? You see left hand side I am getting the data points I marked to the left hand side diagram. You see some of the points are round, some of the points are cross. Okay, so these are the two class label. These are the two class label. So if I draw one straight line, it will easily separate the two data sets. So our intention is we want to separate the two data sets with the help of the one line. One line has to separate the two data points. One is enough. That is a one line is enough. Okay. You see the right hand side. Normally, simple example for non-linear separable problem is you may know that the XOR gate. So XOR gate is the one of the best simple example for the non-linear separable problem. So what is the meaning of why we can say XOR gate as a non-linear separable problem means you see the input data x1, x2. Normally you know this is the truth table of XOR gate. You know the truth table of XOR gate. So if both the inputs are same, your output is 0. Your input is changed either 0, 1 or 1, 0, then only we can make it is your output is 1. So now I plot your value x1 and x2 here. I cannot make the single to separate the output. You see, so your blacks, so both the dotted blocks are it is 0. Both the crossed 0, the not filled the black one, that is also 1. I cannot segregate. I cannot, if I draw the lines here means here I will not make here. Simple thing is that the single line we cannot make the separate these two data points. So that means only this problem we can make it is a non-linear problem. Here see how we are drawing the line should goes like that. So then only we can make to divide the two data set. So this type of problem we call as the non-linear separable problem. So your single layer perception is used for the left hand side diagram because there's no processing. Whatever you are inputting the data, you will get the output. There's no internal process. But here we got to do something because it is a non-linear separable problem. So these type of problem only mostly your multi-layer perception will work. So this is the multi-layer perception. So multi-layer perception in the sense your input layer is there, you are getting the data, you are passed the data to the output layer. Okay. So in the that is output layer, in between we are using the hidden layer. So the hidden layer will process all the data. So all the processing will be there. Whatever already told you, if you are, take one neuron, one F, one is it is a one node. If each node, this one is the one node, each node will process, receive the input data, summed as multiplied along with the weight, added the each node is associated to the bias, and the output of the bias after outputting we have to give the activation function. After the activation function output only input to the next node. So each node we have to do the activation function is processed in the each and every node of the network. So this is a multi-layer. Multi-layer, multiple or multi-layer means more than one hidden layer. Internally we are using, it is not a matter of one hidden layer. We can use n number of hidden layer, depends upon the requirements. So how to select the number of neurons in a network? Definitely you may ask one question. Sir, what is the range of, what is the requirement of how many input layers? What is the output layers? How many hidden layers we can use? So input layer is depends upon the how many features you are having. Your input is 5 feature. You have to, because what is the role of input? What is the role of input feature? Sorry, input layer. Just to pass the input data to the next level. It is not processing. So how many features you are having, accordingly each feature has to associated with one neuron. So you are having 100 feature. So you have to need the 100 neurons. Suppose your image, your input data having the 1000 features. So you need the 1000 neurons. So all the features are associated with the input layer. And the output layer is, if you are having the binary classifier, then it is a 2. Depends upon the how many outputs you are. For example, I will show one example. In our example, we are having the one image data set is there. In the image data set, we are having the 10 objects are there. Already it is a preloaded objects data set. So here 10 objects are there. So the objects are, for example, cat, dog, ship, aeroplane, like that. So our output should be 10. So it depends upon the how many class predict output layer you want or how many class label is there. So accordingly, you have to set the output layer. So output layer is depends upon the output. Okay, number of classes you have to classify. And there is internal hidden layers. Hidden layer is there is no standard rule. There is no standard rule for the hidden layer. We have to use some thumb rule only, but we have to design that hidden layer properly. Otherwise, it will lead to the, you can add any number of hidden layers. If you are adding more, then we have to face there. One is underfitting problem or overfitting problem. So that is the, what is the symbol one thumb rule they are using. You see the number of neurons in the hidden layer should be between the range of number of neurons in the input layer and output layer. So that is this is the one thumb rule. It is not stick to that. We have to follow this type of rule only. You can optimize, you can change the rule also. Design the neurons, number of neurons depends upon the your choice also. But they are saying that if you are adding unnecessary more neurons, it will give the overfitting or underfitting problem. Or mostly it should be at least 2/3 of number of neurons in the input layer. So that is the range of hidden layers we got to use. Okay, this is a non-linear. So now this is, I hope that now you can understand the concept about the one neural network. So neural network means you have the each neuron, each node that you have to receive the input. So it is associated with the bias along with the activation function. So what is the role of bias? Bias will shift that, whether we have to shift the right to the activation function, left or right. So that means the use of the bias. And it is, that means it is acted as a whatever the linear equation you acted as C, the role of C is the same as here. Okay, that is the role of your C intercept value. Okay, bias value. And the activation function, how you are going to activate the your neuron. You are getting the input data. Based on the input data, how your neuron should behave, how your neuron should act. That is we have to define by the activation function. So now we will move to the, now I am going to explain one neural network. So we have the more neurons are there. I am going to see the only one neural network. You may have heard that some of the neural networks are there. One of the popular neural networks, CNN. CNN is nothing but convolutional neural network. So here one of the core concept here is that we are using the one processing, that is a convolution. So based on that only here we are defining the name as a convolutional neural network. So another neural networks are there. So this is CNN is mainly used for the image classification. Suppose your problem is some time series data analysis. You are having the image only. So mostly neural network is mainly used for the image classification. Nowadays, Mani session also told you. So lot of research projects are nowadays they are going to do in the deep learning process, because one advantage is there's no feature extraction process. There's no feature extraction process. It automatically extracts the important feature, because it is sometimes it is very difficult. We may avoid miss the some of the features also. But here no need to worry about the feature extraction. It will take care automatically. and it will predict accuracy also more result. Otherwise, if you are normal machine learning, image processing is not possible. It is very difficult. While you are comparing deep learning, it is very good for the image processing data, especially unstructured data. And one more thing, so nowadays most of the data, I cannot say that always my data set is structured data. So now the data set is, most of our current data are unstructured data, that means the form of image or in the audio, video, whatever, it is not in the structured format. So your algorithm, or you got to handle any type of data, so that only nowadays deep learning is dominating in that your data analytics part. Okay, so I'll tell the RNN is mainly for the time series data. If you want to do the some time series analysis, you prefer the RNN neural network. RNN is nothing but recurrent neural network. So here, just those who are having the image processing, they may get the very good idea. For them it is easy, because internally how the image processing means, how they handle the pixels, filtering concept is there. So it is almost closer to the image processing concept. So normally everybody we know that normally our images are in the form of two forms. One is that grayscale image. So another one is the color image. Normally everybody we know that. Normally your input, here your algorithm process your input is that image. Your input to that our neural network is that image only we are giving to the image. In the image only we are going to give us the input to the neural network layers, input layer. Okay. So if it is a color image, means we got to represent the color image with the help of 3 channel. Normally we call it as the RGB. If it is a grayscale image, then we got to use only 1 channel for represent the grayscale image. There's no 3 channel required. Okay. So for color image, we have the 3 channels. We need the 3 channels. So then we got to how we are representing each channel, having the input matrix is there, and the number of channels. You see X and A and B, and here we have the 3 channels are there. 3 channels are there. 3 means here because we are using the 3 layers. 3 channels are there because only 3. So here I am saying that, for example, one color image. You see one color image, size of the color image is 100,000 pixel into 1000 pixel. Okay, it is a image that this is the size of, normally your image is normally will represent the pixel. We represent the images in the form of pixels only. You assume that this image pixel is 1000 cross 1000. Okay, then you imagine that how many layers required, how many input neurons required to receive the node, to receive the features, to gather the feature. So already I told you 1000 into 1000, and it is a color picture. So into 3. So 1000 into 1000 into 3, almost 3000 billions required to gather the input data. If your network is fully connected network, I will tell you what is fully connected network. So if your network is fully connected network, means you imagine that how much input data is required, how much input neuron is required to receive the data. Okay. So why we are not using the fully connected network? Why we are go for that CNN? Main advantage is no need for the this kind of neuron is not required. Okay. So we will convert to the pixel into pixel range. So according to only we will use that neurons to receive the input data. That we will explain later. So here you assume that if it is a fully connected network, you assume that if it is a 20 cross 28 is a pixel, means you mean that how many layers are required. Fully connected means all the layers are connected with each other. That is a fully complete full connected network. It's just like a mesh. So all the neurons are connected with all the internal neurons as well as all the output neurons. Then you imagine that how much weight matrix is required, because each link is associated with the matrix. Then you imagine that how much amount of weight matrix is required. So it is a huge kind of things. If you are comparing with the CNN, these kind of things are negative. It is not necessary to link each node along with all the associated internal layers. It is not required. It is randomly only they are assigning, connecting that. It is internal only. It is random kind of assignment only. Because of that only we are going shifting from FNN, that is sorry, fully connected network to the CNN network. Okay. So normally how will you represent the one pixel? Each pixel already you mean you know some of the image processing, each pixel is represented by 250 into 255 into 255 each pixel value. So that means that 255 into 255 is used to represent the one image. So here how you are representing, for example here 0 in the range of value means 0 to 25. You see this is the number 8. Number 8, how you are representing that? So whenever one cell I am having the value 0 to 256. So here there is no zeros. There is the value is light. There is no data is there. Then the value is 0. So wherever the particular data, the intensity is more, accordingly the value will be there. So the value should be in the range of 0 to 255. So wherever the value is 2, see here the inner part is more dark. Complete that is filled. So here value is 255. So normally our input data we have to use in the range of 0 to 255. and this is the input image data. But while you are processing, giving to the input image to, you can normalize the data. You have to divide 1 by 255. Then all your input, the pixel value should be, we have to convert it in the range of 0 to 1. Whether you convert or you are directly processing, that is up to you. Most of the application normally we will convert the process. Okay. Then if you are coming to the convolutional neural network, first you should note that we have to internally, we have to use some of the functions are there. Already I told you, major first function is convolution. So already before that one point is there. So this network is that, what is the network? This is a feed forward neural network. Normally feed forward, another one is a feed backward is there. So we are, whatever we are getting, we are forwarding the input data to the next level. So that only it is the feed forward neural network. So okay, so here what are the major operations are there in, what are the functions, what are the operations we are going to do in the CNN means convolution is the one. Another one is a non-linearity, that is ReLU. Already told you, it's a rectified linear units. Next we'll use pooling, then flatten, and the last part we'll use that fully connected layer. So we'll see one by one how it is thingy. So first thing is that, what is a normal thing? We are giving that input image. So here you see, this is the simple example, simple the flow, how your neural network process. So it will detect what is the objective of things. Whatever you are giving that one input handwritten image. So your task, your neural network model should predict that what with this handwritten object number is belongs to the particular digits. So here digit means our output should be in the range of 0 to 9 only, because only the normally the digit should be 0 to 9 only. So your output layer is 9. So here how many we are using that, how many input layers are there? It is 28 into 28. Okay. So input we are needing that 28 into 28 input layers should be required for receiving the input. So after that you will reduce. It is not fully connected. Fully connected means internally you need n number of more number of hidden layers are there. Here first receiving the input data. After that your size should be reduced. You see next level the size of the data should be, it is 24 into 24 into 1. So next 12 cross 12. Then 8 cross 1. That it is 4 cross 4. So we are not keeping the same kind of layers. We are not keeping the same kind of nodes in the neurons in the almost all the internal parts. So here I will tell you how the first step is a convolution. Second is polling. We are using the max polling. I will tell you what is the meaning of max polling. So finally we are using the, what is a fully, at the end of the, already told you, at the end of the things we will use that one fully connected network. So then finally we have to predict the output value. Okay. So what is the convolution step means? So what is our first aim? Normally, what is the general procedure? The machine learning, whatever you are giving the input data, we have to extract the features. We have to extract the features from the input. You see, so this is general. You see, I want to extract the features from the pixel value. So wherever the values are coming above the high density value, that is are the features. Correct. So no need to consider the 0 points. Our intention is whether the digit is 8, whether the digit is, we want to identify that whether the digit is 8 or not. Here so many zeros are there, no need to worry about this. Each number, each pixel is associated with the feature. Each pixel is associated with the feature. According to that, handle the exact the feature only. At the end of the time, we can say that whether it's a 8 or 2 or 1 or 0 or 9. Okay, according to the density of the pixel value of the each cell. So here no need to worry about the 0. Only the important features is, and the number is on. It is enough to identify the things. For that only. So what is the first thing is, we have to extract the features. We have to extract the features from the input image. So that extraction is the process normally we call as the convolution. Convolution is nothing but in CNN. So that is used to extract the image. How you have to extract it? To make the relationship between your pixel value. For extracting the images, or you are making the relationship with that particular one pixel of the image, you need one more concept is there. Normally we use as the filter. So filter or kernel, or we can say that the feature detector, the associated with your convolution to extract the features from the image. Okay, so after extracting the image, extracting the features from the image, so the output of the matrix or map normally we call as the feature map. Next we will see. So here it is my input image. For example, my input image is 6 cross 6. Okay, this is the input image of your CNN. First you are giving to the input. So next one is that I am using that. I told you for extracting the features, we have to use that one filter also using, we are using the kernel. So kernel is nothing but just a feature, just a filter. So the filter, with the help of the filter, we are applying the filter against the associated with that input matrix image. Then we are getting that, generating one more map or one more matrix. We called it the feature map. How it will works means, then what are the various filters are there? Then I will tell you the next slide. You see, so this is the my one filter. The value of the filter is 1 0 minus 1. This is the value. How it is functioning means, so the 3 cells, you see, I plotted, I place against with the moving at top of that your input image data. That means the 1 0 minus 1, 1 0 minus 1, 2 here 1 0 1 0 1 1. So now top of the 3, the corner, I mapped the input filter value. Now you multiply 3 into 1, what is the value? Then 0 and 0, 1 into minus 1. So I multiplied all the values are against with that digit numeric the decimal numbers associated with, I multiply with the filter value. After I am summing all the value, finally I am getting a -5. So here it is a -5. Now this is 1. Next, we got to stride that cell, the filter against the next movement, next 3 matrix. So initially, how I got the next cell value means, so initially I mapped the filter in the first 3 cross 3. Now I shifted, my stride is, I am shifting one cell right to that. Sometimes you are defining your stride should be 2 means, here you got to shift it into the 3. Okay, here you got to shift that into the 3. So now my stride is, if I am using the stride is 1. So now second position value is here. Then third will come from here and fourth will come from here. That means your 6 cross matrix input image is now reduced into 4 cross 4. You got it? So initially your input image size is 6 cross 6. Now your input size of the matrix after the convolution, your size is 4 cross 4. Further only here we are saying that, you see your input is 28 into 28 input size. After the convolution step, your map is, size of the map is reducing. So like that only it is processed. It will process all the data. So finally we will get to that. After it moving to the each position of the each 3 cells, finally we will calculating that you are applying the filter value, do the some arithmetic addition only, multiplication and addition only. So accordingly we will get the value in the all the feature map value. So this is the output of the convolution step, output of the first step. So input stage is you are taking the input image, so you are doing processing along with the filter. So after filter, your output is that 6 cross, your input is 24 cross, now you are getting that, what is that, 4 cross 4. Similarly, your input is 28 cross 28 means you will get into the 24 into 24. If it is a colored image means 3 channel will be there, grayscale means only 1 channel will be there. Here, what are the normal standard filter we will use? So most of the use filter mostly used for detect the different features. Okay, normally your filter will use to identify the particular object, or most of the things you have to use for the edge detection. Already those who are image processing, they may know more very well about the process of, if you have to detect the edge, whether vertical edge or horizontal edge, according to the detection of the things, here we are using that particular images. So your filter is used to extract the different features, whether edge or curve. You see this feature we have to use for, this is an image, how you are extracting, which type of data we got to give more important to extract from that particular data. So whether you are using identity filter or you are using edge detection filter or sharpen filter or blur the image or Gaussian filter, so according to that we got to apply the filter value. It is not matter that you got to apply the only one filter. You can use all the filter also to extract the image. If you want to extract the edges, or I want to extract the curves, or I want to extract the blur also, you can use all the filters in the one setup. It is not matter that you got to use the only one filter, but we are having the standard filters are there. If you are defining particular one value, it will behave, we are giving that according to, it will extract the features from that image. So this is the role of features. Okay, here and another in the features we are setting that feature, here we will use that stride. So how many depth mean how many filters we got, whether you was the only one filters or you want 2 filters or 3 filters, that is that we have to define in that depth option. Okay, so whenever you are defining the CNN network, we got to define the parameter. So the depth define that how many layers we are going to use, how many filters you are going to define in the particular processing. And the stride means how many cells we are, I told you that we are shifting 1 cell right, or you are shifting the 2 columns right, how 1 column right or 2 column right, that we got to define the stride function. So another one important thing is the padding. So normally the padding will be 2 types will be there. One is option is valid, another one is same. What is the meaning of thing means? So here you see, here we are using 2 cross 2. We are map actually where we will use the padding means the pooling step we will use the padding. What is the meaning here means? You see, so my padding size will be 2 cross 2. My padding size will be 2 cross 2 means first 2 cross 2 here I will map the value. So what is the maximum value here in the 4? The maximum value 11. So here after I am padding the value, putting the value, what is the maximum this 4 cell? It is a 5. So we are not considering the last one. Only from the matrix, if you are giving this is the input matrix, it will give the output only like that only. If your option, if your padding option is valid. Suppose already you know that the padding is nothing but adding zeros. Normally, we will already you studied the some of the concept. We will use the term padding. So padding is nothing but you are adding some zeros. Okay. So here, if you are choose the option padding, the same means what will do means. So here I am considering these 4 cells. What is the maximum value? 11. So earlier, if you are using the padding valid means we are missed the one complete column. So if here we want to include, if you are take that also column also, then you have to use the zeros. Then accordingly you select here 4. What is the value? Because if you are adding 0 means it will not give any impact. Suppose if you want to give the weightage about the last cell also means, then you have to use the padding option same. Don't want that one, then you have to choose the option padding valid. Normally we'll use the padding. 2 options are there. One is the valid, another one is the same. Okay. So what is the non-linearity? Already told you ReLU. So this is the in the diagram you see processing. So you are using that convolution plus padding. So along with the padding, we got to use that ReLU also. Okay. Here, what is the padding in the sense? I will tell you. Suppose here you are sliding one. Suppose sometimes what happens that you may miss the last cell. We are placing that filter value in the top of the things. We are shifting one by one. Okay. Sometimes what happens? There's a chance for you are missing the value. So for that to avoid, you need that value only. We are using the padding. Whether you had the 0 padding or same padding. Okay. And already told you along all the convolution, all the processing, we have to use the one function that is ReLU. So what is ReLU? So whatever you are getting the input, it will consider only the maximum input. F of x equal to 0, x, it will take the x value only. So maximum, whatever the 2 input we are giving, it will give the maximum value about the particular input. Okay. So this is the input data. For example, I want to identify the particular image. So in the particular image, you have the black dot also there. You have the white dot also there. So if you want to identify the particular image, so we have to give more importance on the white background only. So you have to neglect the black background. So here you see, your black ones are you have treated as a 0 and the white ones are you have to treat it as the 1. So if we are giving 0 and that x that value, so it will take only that particular value only. This is the input before the ReLU. After the ReLU, you see the output of the diagram. The image, there is no black symbol. There is no black dot. That is the one. You see left hand side, this one, till the 0, there is no change in the output. This is your f of x. This is the ReLU function. Till your input data is either minus, -1, -n, whatever it may be value. Till the 0, the function will not get activated. The function, when the function will trigger, once the value is reached 0. After the 0, you take your input value to compare to the 0, whichever giving the max value, then only we have to give that. So whenever you are extracting the image, so we have to give the importance to the only the particular highlighted features only. We don't want to the particular darkened image. So that only we have to use that ReLU function in the along with the your neurons. Okay. So next step is the pooling step. So far what we did, we have to extract the features. We have to extract the features with the help of the convolution. In the convolution, we are using that filter. Along with that, we got to use the one more function is there along with the ReLU. Okay, that means the one activation function. So after that, so now what is that? This is the feature map. So output of the convolution is giving to the pooling step. So it is a second step. The pooling step, what we are doing? So here we have to take the more weightage parameters only. What is the pooling? Suppose I am having the features are there. Among the features, whichever the features is more weightage features, that only we got to going to extract. That we got to done with the help of the pooling step. So here the pooling normally max pooling, average or sum. 3 type of poolings are there. So here what is the maximum pooling is? You see, so here my pooling size is 2 cross 2. It is a pooling size is 2 cross 2. First I place the here in the top the 4 cells. It is 2 cross 2. What is the maximum value? Maximum value is 6. So then the 2, 4, 7, 8. What is the maximum value is 8. So then 3, 2, 1, 0. What is the maximum value is 3. So it is what is 1, 0, 3, 4. If it is a maximum value is 4. Suppose here you are having one more 0 is there. You want to that value means you have to apply the valid padding should be. You have to use the padding should be either 0, same or 0. If you want to neglect means you put the valid. You want to consider that column also. Then you put that padding option as the same. So now what is the size? You see your input size is 6 cross 6. So after the convolution, your size of the matrix, size of the feature map is 4 cross 4. After the pooling step, your size is 4. Sorry, what is the size? 2 cross 2. So here only here we are showing that. You may think that why the size is of the here you see. So input is a 28, 28. So 24 after 24 exactly after the pooling. Here also we are using max pooling. So after the pooling, your channel how many image size? What is the image size is only 12 cross 1. Okay. So this is only how the pooling is going on. So after that, so what is the pooling after? Okay, we are applying the max pooling, using that convolution, we extract the features. Then after the pool, then we given to the pooling. In the pooling, we are identifying the what are the features are more important features. That are the value we are extracting from that particular one thing, particular image. So after that, we are flattening. So flattening is nothing but from the object, we have to make it is a one-dimensional. Earlier you see, earlier it may be 3 cross 3. Now we'll make it is a single dimensional vector value. Okay, we are converting. So this is the now input, because we got to give the all the input data to the fully connected network layer. Now your 4 cross 3 cross 3 matrix value will be converted to the single vector value. Now the single vector value is given to the fully connected network. You see, after flattening, after you are flattened the value, now you see after the flatten, your input data is in the form of matrix, your form of matrix. So after the matrix format data, we are giving to the input flattened. So flattened, what it will do, it will convert to the your two-dimensional data into the one-dimensional data, into the single vector format. Okay, so this single vector format we have to given to the fully connected network, because now your data is correct. Earlier, you see, earlier your image size is, what is the size of the image? Now your image is only the 9 vector only. So how much? Then input is 28 cross 28. From the 28 cross 28 image, now we reduce to the 9. Now this is you can give to the your fully connected network, because fully connected network means each layer is connected. All the layers are connected with the another layers. That means it is just like a mesh network only. So now earlier, if you are directly, if you are giving that 28 to 28 means, you imagine that how much neurons network required, how much weight association is required. Now it is very less. Hereafter only we are going to form a fully connected network, because now your input is only 9 only. So you need the 9 neurons are required to receive the input, because from the input image we have to extract the important features only. That important features only, now you are going to give the input to the fully connected network. So that is a concept. Here you see. So now you see only the 9. Whatever things are required, these things only we are giving that. So here itself, finally it will predict the your output data. So here, this is the fully connected part. Already told you what is a fully connected one. Okay. Here in the fully connected network, we will use one function, that is a softmax function. So what is the use of softmax function is, it is we got to map the your output data to the some. You see here this diagram, you can explain the things. So after the output of the layer, means fully connected layer. Okay. The output is a fully connected layer. So the fully connected output layer, it will give some of the value. That value we got to map with the some probability of distribution value against with the class label value. So what is the thing is there? What is our expected output? I am giving the one digit or one image. So that image we got to say that whether the image belongs to the cat or dog, or it is a particular and a bird or sheep, whatever it may be. We got to identify there this object is belongs to particular. We got to classify the object. So whichever the object is having the highest probability value, so that value, that object is belongs to the particular one. You see, normally you know that the probability should be in the range of 0 to 1 only. So whatever your input values are there, we map all the input value in their probability, the distribution in the range of 0 to only. You are having 10 features also, you are having 100 features also, or you are having 2 features also, we got to map with the 0 to 1 only. We got to mapping the range of input to features vector value into the some probability distribution depends upon the class features. For that only we are using the softmax function. You see the input of the softmax function, the range 5 values are 1, 1.3, 5.1, 2.2, and some values are there. So you see among the values, which one is the highest value? 5.1. So that means this feature is give more impact to the deciding the particular object. So you see output of the probabilities also. Already told you probability should be in the range of 0 to 1 only. So here among comparing with all values, this is 5.1. So almost 0.9. So you add all the value, your what is output? Your output should be 1 only. You are summing all the probabilities of all the values. Your result should be, you see 0.2, 0.90, 0.5, 0.01, 0.01. You add all this, your sum to be 1 only. So if we are mapping that all the input features of the your convolutional neural network to probability distribution mapping with the class label. So for that only we are using the softmax function. Okay. So this is that, and finally it will based on that we will predict that whether this output is belongs to which image. So here overall we can see that. So your convolutional and pooling layer will function as the future extraction. Your input, your machine learning process, your data pre-processing is there. So your pre-processing step is there, then classifier is there. Your convolutional in the CNN network, your convolution plus pooling layer is acted as a feature extractor or feature engineering, that is using the data pre-processing, and your fully connected network is acted as a classifier, because internally we need two parts. One is the feature extraction or the pre-processing, another one is a classifier. In this your neural network concept, your CNN concept, your convolution plus pooling, these two function is acted as a feature extraction, and the last one, your fully connected layer, is acted as the classifier. Okay, so this is the one. These are the some of the limitation of the deep learning challenges. What are the limitations are there? Okay, so here now I will show one implementation part in that Keras. You may have heard that the Keras or TensorFlow. So TensorFlow is the low level, Keras is the API level. So it is a top level API interfacing is there. So this is used for the image processing. For image classification problem, we have to use the Keras as well as the TensorFlow. It is a one. And another one, we have to use this one. Otherwise, it was image classification. This is the one of the important library, most important library module available in the Python. That is Keras and TensorFlow. Using that, we can extract. We have to inbuild. You have to process all the image classification tasks. So another one important thing is, whenever you are set up the TensorFlow Keras, you have to create the separate environment, separate setup. So if you are working on the Jupyter notebook, it is very difficult. Normal Jupyter notebook in Anaconda setup, your TensorFlow Keras, it won't work. So we have to create the separate environment. So normally I face lot of times the problem, it won't work properly. So better you run the image classification, this type of problem in the your Colab. Okay, so now I will show you one small demo. So this is the Colab only. Okay, already you know that this is a Colab setup. So Colab is also nothing but it is a cloud. So complete hardware services they are provided by who? Your cloud, your Google Cloud. If you want to run that, if you want to use the Google Colab, means you should have the one Gmail account. If you are having the Gmail account, you know how to open the things, because already the last 3-4 days your complete practical sessions are you are using Colab only. So I no need to explain more about the what is a Colab. Okay, first thing is we got to connect. What is the thing? So they are providing their complete setup for run your all the Python programs. Here no need to install any library. Your TensorFlow Keras already inbuilt they installed. So it is very convenient comparing with your Jupyter notebook. So if you are doing some deep learning problem or image processing classification tasks, or whether you are using CNN, or if you are using, suppose if you are moving object detection means, then you have to use OpenCV. You may hear that in the computer vision, OpenCV is the one of the libraries. So that is mainly used for object detection, moving object detection. So that library are already inbuilt in that your Keras, is inbuilt your Colab. So no need to do any additional kind of setup. So it is more convenient. Okay. So first thing is we got to run, because we got to run your Google Colab setup on top of your machine. We are running that cloud machine in the top of your machine. This is also one kind of cloud setup. So for that only, first we got to run. You know that already. First you got to connecting the things. That means your notebook, your Google Cloud is connected to that your environment. Okay, now initializing. Now it is connected. So here see, so now they allotted some RAM size. You see how much RAM, almost 0.76 GB to almost 12 GB RAM size, and how much hard disk they are allocated this much spaces for the particular notebook. So this is the one. So this is the one image classification problem. I will explain you how the problem is working. Okay. So this is that problem, the data set. First we need the data set. So already in the Keras, they are having some built-in data sets are there. You no need to worry about the data set. Already they are having a lot of inbuilt-in data sets are there. So I will tell you what are the data sets are available here. So if you go, this is Keras. If you open the Keras, they are having some more standard data sets are there. These are some of the data sets already available. So okay. So MNIST data. Suppose if you want to do this, I told you some image. Sorry, the object handwritten object detection classification means this data set is there. Now here I am taking this data set. CAFIR. Okay, this is the one of the data. CAFIR means it is a Canadian Institute for Advanced Research. So this is the name of the data set. They are having the 10 images. They are having the 10 class of images. Totally they are having that almost 60,000 images are there. Okay, 60,000 images belongs to the 10 classes. Total overall 10 classes combined all put together, they are having the 60,000 images are there. So already told you, for image, if you are using the deep learning, your data set should be more. Then only it will give the more accurate. Otherwise, it will give the overfitting problem will be there. Okay, so this is the data set. What these are the standard data set. No need to download anything. If you want to download your own data set also, all the data sets are available. Early morning I told you, either GitHub or Google, all the data sets are available. Okay, now I will explain, and later that I will show you. So here, so this is the first, I will give some explanation about the what is this data set. So it is a CAFR, it's a very popular computer vision data set. So they are having the 60,000 images are there. So imagine totally they are having the 10 classes. Okay. So what are the classes are there means airplane, car, bird, cat, deep, dog, frog, horse, ship, and truck. Okay. So these are the objects they are having. These are the objects already they are having. Okay. So our input is using the data set, using the 60,000 data set. So we have to build the model. We have to build the model using with the help of the CNN. This that means the convolutional neural network. We are defining the CNN according to the setup. We have to give the input data set. This is the input data set. So we build the model. Then we got to give one unknown new object. Then we got to check that how your model is predicting. Is correct. So this is a normal task. So we got to build the model with the help of the past data set. So CFAR data set. So this using the data set, we are going to build the model using the CNN. Using CNN algorithm, we are going to build the model. So after building the model, we'll give some input data. Then we got to check how your model is predicting the data, whether it is correct or not. Okay. So now, so this is the some information about the things. So then we got to import, already told you, for example, I type that imported TensorFlow. Just once you click, already you know the Python, the command execution in the Google Colab. So you know about that. This is I'm using the TensorFlow. Okay. So from Keras, I am importing the data set. So CAFR, this is my data set. So here I am using TensorFlow is the backend. So under Keras only, we are using Keras is the top layer. So below the Keras only, we are using the TensorFlow. Okay. And this is, you know, that the library for the visualization one. Then you know that whenever we are doing the data pre-process, whenever you are the building the model, your data should already told you what is the steps we got to follow the data, the building the model. So your data set should be divided on the training data and the testing data. So how to do we follow the procedure? 80% of the data we are using for the training data, test data. Here normally the standard rule is if you are not specifying anything, it will be there 80-20. Mostly I hope that. So by default, because we are here, we are not using any fractions. Okay. Your input data, you see it, your CFAR load data. Now the data set is divided into 2 of. What is the output of this function? Your data set is train X, train Y. That means 80% of the data and remaining 20% of the data divided into test X and test Y. Okay. So these are Y means what is the meaning of here Y? Predicted output. So the rest of the all the attributes are belongs to the X. Train X that goes to the all the X attributes. So all the features and the last column feature, that means your target label, predicted output label only Y. So we are dividing the 2 data set. Okay. Here just nothing but display the object. So these are already frog, truck, some that lorry kind of things, car. So these are the some of the objects. This is I think the goat something. So these are the images. Already it is predefined images. There is just a display purpose. I am showing that. Okay. So then we got to download it all the, we got to access the Google Drive. All the files if you want to access from the Google Drive means you got to mount the Google Drive. Already you may know that this is the command for mounting the Google Drive. Okay. So this is the more important thing. So hereafter only our real whatever we are studied theoretically, same setup only we are going to do here. So first one is that already told you we are using Keras. From sklearn, whenever, for example, when we are doing the linear regression also, what we'll do from sklearn dot to import, from that only we are importing the regression model, linear regression model, logics regression model, the same thing only. So all the modules are available from Keras. Now we are using Keras only. From Keras dot models, we are using the sequential. So first thing is what type of neural network CNN model, what is the model of, what type of model we are going to use. So our model is sequential model. So sequential means first input layer, next hidden layer, next output layer. The layers are organized in the sequential manner. So that is a sequential layer. So next one is the first point. I hope you understand the thing. Second one is the dense layer. So dense in the sense more congested. Normally the word dense, where you use the word dense. Dense means more congested type of things. So here dense layers, the sense finally we are using the fully connected network. Your fully connected network means all the neurons networks are connected with one node with another nodes. This associated with weight also. So in the output layer, in the fully connected layers, we are using the dense layer. Dense layer, it is a, already I told you in Python, all the setup, it is a plug and play only. So whatever your setup, no need to worry about the coding about the dense layer. No need to worry about the coding about the internally, what are the things are there sequential. If you are designing the dense layer itself, it is a long coding process there. We don't want to do anything. What type of setup we are, it is a plug. Whatever type of the modules we are going to place in the constructing the model. So that is a dense one. Okay. So another one is that this is the sequential model. So dense layer, it represents the fully connected layer. So another thing is the dropout layer. So what is the meaning of dropout layer? Sometimes your model may be predicting some overfitting. Okay. So it may predict some overfitting may be there. So we got to drop out the overfitting value. For drop out the overfitting value, how much fraction we got, whether 1% or 0.5%, how much drop out we got to use in that features out, because we will not take all the features. So internally, your one layer, we are extracting lot of features are there. In each layers, we got to remove the some of the features are there. To removing that features only we got to achieve with the help of the dropout function. So another one is the flatten. Already we know that what is the flatten. Another is the max norm. So what is the max norm here in the sense? So max norm will be defined there. What it is some constraint value. It is some constraint value. The value should be maximum 3 value. So what is the maximum value will associated with the particular weight of the each link. So that is defined by the max norm. Okay. So another, this is the more important, that is a SGD optimizer. So another thing is we have to use the some of the because here we are not doing any pre-processing. Imagine that one thing is more important. Earlier all the machine learning algorithm we are using the pre-processing, lot of stages are there. So here we are not doing any pre-processing. Everything is taken care by the internal layers only. For that only the layers we are defining more number of functions. We are giving more overhead to the all the layers. So what is the meaning of optimizer? This will work in the hidden layer as well as the output layer. So what is the use of optimize layer? Mean it will reduce the loss function. So what is the use of our ultimate aim is you have to get the more accuracy. When you will get the more accuracy, you have to reduce that your loss. You reduce the loss function. How you are reducing the loss function? Mean we have to introduce the optimizer. So in the optimizer function, aim of the goal of the optimizer function is to reduce the loss function. How it will use that? We got to adjust the weight along with the learning rate. That will also tell you. So what is the thing? So many optimizers are there. Stochastic SGD means stochastic gradient optimizer. Adam optimizer there. Optimizer itself is a huge concept. If you get all the if you are open in the Google net, you are typing the optimizers in the CNN network means you will get, it will list some 7 to X optimizers are there. Each optimizers having the some important features are there. So the main concept is to reduce the loss function, to improve the accuracy, and it is used to adjust the weight along with your learning rate. So that is the main concept of your optimizers. Okay, then after that, what is the convolution? How many convolution layers you are using? Here we are using 2 layers, two dimensional. That is, one is the for convolution, another one is we are using for the filter. For that only we are using that convolution 2-dimensional 2D. So in the convolution 2D, internally I told you convolution we are allowing we are using the one more function, that is pooling. What type of pooling function we are going to use? We are using that max pooling operation. So this is the max pooling. So this I hope you may understand all the things. So next we are using import one NP utils. What is the figure of NP utils means? Suppose sometimes what we want to do is, suppose we got to categorical, sometimes we got to convert your categorical data into the numerical data. Internally we are processing, all the processing are numerical data only. All the your processing are numerical data only. So we got to convert your numerical data into numerical data, categorical to numerical. We got to do some utilities. We got to convert some process function should be there. So that functions are available where it is available the utils. So util is one of the module where we are importing that np_utils. So this is the first setup. So this is what are the things. This is our create the convolutional neural network setup. So this is first we define the setup. So after that, already told you your input data, all the values are represented in the 0 to 255 pixel value only. So we have to normalize the value between the 0 to 1. So how do you normalize? Whatever the input data is there, particular the data value, pixel density value, divided by 255, you will get the normalized value. So the value should be in the range of float 32 value. For that only we are using your train X type of, what is the type of the value? It is a float 32, your X. Then your input data value, whatever the train X value is there, already one value is there. That value we are dividing by 255. Now your output is, your train X value should be in the range of 0 to 1. Similarly, your test data value is also in the range of, what is the range of value? In the range of value in the 0 to 1. So this is, we are normalizing the data set. First we are normalizing the data set. So this is, I told you. So this is we have to use for the utility function. Where you are applying the utility function? You see my utility function where you are applying train Y and test Y. Okay, what is train Y and test Y? Train Y is the your last predicted output, your last class label. Your last class label is whether it's a dog or it is a cat or it is a ship or car. So now it is a categorical value, but internally we want to process into the numerical value. We got to map the value. We got to map the value 0 to 1. It is a numerical value only, so that your Y label data should be converted into numerical value. Initially, all your the last class label value, the predicted value should be the class label. That value we are going to convert into the numerical. For that only we are using that utility function. So already you may that one hot encoding. You may know that what is a one hot encoding. These are the, it is a categorical to numerical. So what are the other encodings are there? You can use the label encoding is there. You can use the hash encoding is there. You can use so much of encoding teams are there. So that we have to use for that. What is the things? The categorical to numerical processing. Okay. So number of classes, test.y shape will give the total, how many classes are there. Total 10 means it will give the number of classes equal to 0 to 10. That is a value. So now first we set up everything. First I set up what are the layers we are going to use, whether we are going to use a convolution layer or whether we are dense layer. Then from that particular layers, how many layers, whether 3 layer or 1 layer or 5 layers, what is the maximum normal value, what type of activation function we have to use, all the things we got to set up. That is the initial model we are defined, this type of model. Now we have to create the model with all the layers, with all the whatever the possible values are there, we got to give. So okay, my model is sequential model. You see now I am adding that conventional 2-dimensional. What is the thing? 32, 32, 3. That means here input size is 32 into 32. And how many filters we are using? 3 filters we are using, because it is a color image. In the first I told you color image means we need the 3 channels. So here we are using 3 cross 3. So this is the your input size, 32 into 32 into 3. So what is the maximum constraint using? The associated with the maximum 3. And the dropout I am using 0.2%. The features we having that we have drop out some of the features. So value, whatever the value is giving, it is 20% less than the value we are dropouting. So this is the convolution. And what is the activation function we are using? ReLU. Here we are using the ReLU. And already I told you padding. Here you are padding. Here we are using the same. Or sometimes we may use the valid paddings also. Already theoretically explained what is the meaning of padding same and what is the meaning of padding valid. So these are the kind of setup we have to set up everything first initial stage. Okay, my actual last dense class. What is a dense? Dense is already told you. It is a last one. Last your fully connected layer. So how many classes are there? 10 classes are there. What is the function we are using? Activation function. That means whatever the categorical value features, that value will be there. That value we are going to map to the numerical probabilities between the ranges of 0 to 1. If you sum all the together, we will get to the 1. Whichever the features probability highest value, that is belongs to the particular object. Okay. So this is the setup about the model. So once we are set up a model, we got to define the landing rate. So landing rate also one of the important features. What is the use of normally landing rate? Normally the landing rate should be in the value of 0 to 1. Okay, 0 to 1 only. It is used to adjust the weights. Normally whenever how to land, this small just kind of triggering the value only. Normally it will, the range of the value should be there. They are saying that the 0 to 1 only. So it will mainly it will use to adjust. And another one is that decay 0.01 divided by 25. So what is the meaning that? So we have to create the epochs. So how many times you got to run? So mostly normally we'll use that some 20 epochs or 50 epochs. So number of times, how many times we are passing the training data? 25 times or 30 times, 30 cycle process, one batch, 35 times we got to create the data. How many epochs normally we do? So after every 25 epochs your landing rate will be decayed. So when it will be decay over. So after that every 25 seconds, every 25 epochs, what is the value? How much value it should be reduced? So this value is used for last one is it is used for the one of the optimization function. So then another one is the what type of loss function you are using. So here we are using the categorical cross entropy loss function. so many loss functions are there, mean square error or maximum likelihood estimation, that also you can get it from the net. That loss function is, without, our aim is we got to use any one of the loss function to find out what is the value of the loss. So that our ultimate aim is we have to reduce the loss value. Okay. So these are the up to, this is the your initial setup. So now after that, already you know that fit the model. Fit the model means in the linear regression also, this is the one line. Actually, we are set up everything. We set up all the values fitted into the your input training data set. Your training data set, TrainX data set is there. So from the data set, we are going to fit the model. Then that is a fitting the model. We are using the training data set, and validating the data. We are using the test. Okay, we are already told you we are having the 80% of the data used for the TrainX data. And validating the data, we are checking how you are predicting your model. Validating the data, you are using the test data set. So, and the number of epochs, 10 epochs, 10 times you have to, and each batch size is 32. So this is the value we are giving to fit to the model. Now we are fitting the model. The model is ready. All the parameters. Now if you are fitting the model, that means you are executing the model. So after I am running each epochs, totally how many epochs are there? 10 epochs are there. So it will execute. It will take more time. Already I executed. It will take more minimum. It will take minimum 10 times. It will take minimum 10 times. So after that, you see in each epochs, it will give the loss accuracy value. Okay, it will give the loss value as well as the accuracy value also. You see in each epochs value, the loss value will be, it will be reduced. The loss value will be reduced. Ultimately, you see the first epochs to the last, your accuracy value will be increased. So each the value loss means what is the validation there. Each validation times what is the loss is there. And the accuracy mean each value accuracy time, what is the accuracy about the each validation. So this is the file we are comparing each time epochs, we are processing the validation data to check with the value of the loss function along with the value of the your accuracy. So our ultimate aim is we have to reduce the loss value and we have to increase the accuracy value. So according to, we are calculating the what is the accuracy about the my model. So my accuracy about the my model is not up to the level. So according to the setup, according to the parameter setup, it will giving the only 69%. Okay. So now I am checking that. How it is working. Okay. I'm creating one dictionary. I'm creating a one small dictionary. This is a, you know, already dictionary you studied. Dictionary means key value pair. So key, how many already in the your objects, how many objects are there? So we are having the 0 to 10 objects are there. You are having the total 0 to 10 objects are there. So I am giving the 0 means aeroplane and 1 means automobiles, 2 means bad. All the objects are there. Okay, this is all the objects are there. So now my model is over. I run the, I design the model, I fit the model, I calculate the accuracy about the model. Final, what do you think? We got to validate, we got to check the model, how your model is predicting. For that only, what I am giving that, I from the Google, from the net, I downloaded some of the images. Okay, you see, I will show you. So this is, I am giving one image, that is a S3. So what is that? Your S3 is the aeroplane. Similarly, I am having some of the images already there in that one. I am having F1. So this is the frog. This is not a, I just downloaded from the net. I am just downloaded from the net only. I'll show you that image I validate with the model. This I validate this with the model. You see, I told you this is the one image. So I downloaded. Then what is the size? I resize the image into 32 into 32 because we don't know what is the size of the input image here. But internally in your neural network, we process the model with what is the size? What is the size? We process the image with that 32 into 32 only. Okay. So that only already. So yeah, see, already because I didn't executed. So earlier it is shown correct. So among that two, F1 also it predicted, but C1 is cat, but it predicted as a dog. First, so whenever we are running, sometimes it will predict correctly, sometimes it will predict wrongly because my model is not up to the level. So what is I am saying that I downloaded some of the image, I input the, okay, how you downloaded from PL is one of the package, input to the image. So from the image, I opened that one image, given that image. So I resize the image into 32 to 32 because our input image, we are built the model with the help of 32 into 32 only. So then I have to check whether how model is predicted. So my model, first one is predicted correctly. Second one, F1 also frog, it is also predicted as the frog. But here C1 is cat, but it is predicted as a dog. My input image is a cat, it is showing that a dog. So it is a error. So this is totally how we have to set up the neural network. So first we got to define all the first. Before that, you should understand very clearly about that. What are the how your neural network concept is processing. What are the layers are there? What are the models are there? How you got to define the network? How you have to set up the image. So after that, you have to fit the model, then run the model, then set up the epochs and everything. Run after that, you got to validate the model with some given input image. So whatever here the optimizers or loss function, if you want to learn means. So all the materials are available in the things. So they got a lot of loss function, also lot of loss functions are there. Optimizers are also lot of optimizers are there. So according to the your requirement, you got to use. Suppose here I am using some other optimizers or some other loss function means I may get the more accuracy. Maybe we may not say that these are 69 it is only we are getting. Suppose here instead of SGD, if I am using Adam optimizer mean I may get above 75 also, that is possible. So here I tried, I will got this 69 is the percentage. So this is the how neural network we have to use to predict the one image classification. Okay. So up to this is my explanation. After that I will show you. So where, for example, you don't worry about the data set. Suppose I told you, suppose you want to do some COVID-19. I told you COVID-19. COVID-19, for example, some XA data set. You see, suppose some of the people, they are using some deep learning. If you want to do the more kind of projects, research and other means, so many people they are asking, sir, I am not able to get to the data set. So all the data sets are available. And one more important thing is, some of the source, some of the places you may get along with the Python code also. You see, this is the X-ray data set. This is the X-ray data set they use for whether the, because nowadays so many people we are saying that cough, you are having the respiration problem. So respiration problem means you have the more cough. You have the more cough, and that means after then it is normally identified with the help of the ordinary test. So we got to give the input image. We got to extract your X-ray image. Then only we can able to more accurately predicted about whether you have the COVID-19 or yes, whether you are affected with the corona and others. Correct. So for that only we need the some image kind of processing there. So this is data set already available. You see, you can download the data set already downloaded. I can show you also. Maybe some other folder. It is available. You don't worry about that. It is available only. You can download the all whatever data set. If you whatever the your problem, whatever data set if you are using, yeah, all the data. What is your research problem you are using? All the related works, all the data sets are it is available. It is also one of the important site. Similarly, this is another one of the site that is we called as the GitHub. Normally, the GitHub and the Google, these are the two predominant data sets for supporting the your machine learning as well as the deep learning. Here also explore that. Here, if you are time, first thing is you have to create one account. It is not they won't ask any money. You create any account. Suppose I want to get some of the data set for the COVID-19. You want to do the some COVID-19 analysis. Here also same kind of data set is available. Some other so many data sets are there now. COVID-19 CSR image, you see some of the images are there. So along with that, they are giving the lot of data set. They are giving the source code also available. Source code also available along with the data set. So it is not a problem with that, whether the where I will get the data set. So data sets also available, source code also available. You can run and practice. This coding is not a problem because in the Python, you know the all the library, all the built-in classifier, it is a one-line statement. If you want to bring the decision tree means you have to fit the build one line statement is enough. You are invoking the decision tree or random forest. But how you are using, how you are optimizing that particular one model, one classifier is the more important. Okay. So these are the data set. This is the things are available. Now here I am planning to. So I want to discuss some of the things. So these are the some of the recent, some of the long research areas are going on. Suppose if you want to ask about some of the important areas. So first one is the augmented analytics. So nowadays augmented, we are in the most of the part what we are doing is the data pre-processing time. Sometimes what happen means we are missing some of the features. So some of the features may be important by mistake or by your processing, your algorithm may not detect the proper thing. So that only nowadays the augmented analytics, they are simply replacing that your data science concept. So it is a completely NLP along with your AI and the NLP. So that is the main role in that augmented analytics. So a lot of things are going on augmented analytics. You know about the cyber forensics also. So another one important concept, that is a blockchain. You may heard the term blockchain. I told you some of the buzzword will come some of the period. So some 5 years back, 3-4 years back, everybody was saying that big data analytics or some machine learning, some things. After that, deep learning comes. So nowadays, most of the people, they are using the blockchain. And I heard that if in blockchain, if it is very easy to publish the papers, because if you are doing the computer networks, means you have a lot of reviewer, editor, it is very difficult is there to publish the paper. But if you are comparing with the blockchain, it is a very easy. So what is a simple logic blockchain in the sense, it is, we can know that it is a peer-to-peer network. Blockchain means it is nothing but it is a peer-to-peer network. So what is a simple example is, normally, for example, if I want to transfer some money, suppose if I want to transfer some money from my account to your account, means what I have to do. So first I have to log into my bank account. So my bank account people, they have to authorize to my account, my credentials. So then only I can able to transfer. So that means I am money is in my hand. I am going to transfer your account only. What is the need for the bank people? So because now all the transactions we are doing along with the in between the bank only. So one third party is using. So most of the services we are depending with the third party. So the blockchain concept is, without that third party concept, we can transfer the money. We can make the network. So there is no need for the there's no need for the third party. So that is the concept of the blockchain. So a lot of applications are going on. And suppose, for example, now you see one more simple example. I'm saying that in the education also, blockchain is playing. A lot of papers are going on. One of my friend also doing the research in blockchain. If, for example, one student, if you are studying in the Anna University, means now you are all coming under the Anna University. Particular one semester, one student means already the curriculum is defined by the Anna University. Fourth semester, 6 subjects are there, mean they have to study the 6 subject only. The student has no right to choose the another subject. Now they're using the blockchain. What is the option they are giving means, I can, from the what is Anna University criteria, I have to, my credit should be 30 or 20 credit should be I have to score in the particular one semester. So 2 subjects I may score from that Anna University, 2 subjects I may score from the MIT, or 2 subjects I may score Stanford University, or 2 subjects I can select from that IIT. So it is my intention is, because university has not forced me to, you have to study the particular subject only. What is your credit? What is your criteria? You want to fulfill the credits. So I have my choice, my options I have to choose, because some of the university, my interest is some other field. Some of the universities, some of the professors, they are providing some good lectures. So I want to learn particular subject. So far, our university system is not having such a provisions. Later, the provision will come with the help of the blockchain, because it's a direct, there's no in between. So direct to direct, peer-to-peer networks. Similarly, so a lot of applications, research are going on in the blockchain. Suppose if anybody is, so those who want to start the research work, you explore some of the ideas in the blockchain. It is a very good area. So time series analysis, you mean that nowadays most of our data are time series data, then the recommender system, then the edge analytics. Edge means IoT device. So now most of our data are IoT device data. Normally IoT device data only edge data, and most of our data are the graph, social media, social network data. So that is a graph data, and the medical analytics, because nowadays it is a emerging, it is a it's not a emerging, it is a we should do, we have now, because we are facing a lot of problems. So medical analytics also going on. And another is a hyper personalization. So that means the customer behavior test. So what is the customer analytics? What are the, for example, if you are the particular company, they are launching one product, means, so before that they have to do some survey about the customer analysis. So that is a customer behavior, customer personalization. So that is the meaning of that area. So behavioral analytics also. So these are the some of the recent areas. Lot of researches are going on. I'm not saying it is up to limit. So this is some of the, other than that, so many other things are, lot of things are there. Okay, so these are the some research recent trends. So up to here, I am planning to stop my presentation. Okay. So participants, I hope my almost journey will be over. We started. You hope you understand a little bit about the morning machine learning, and how you have to set up the cloud, and what are the metrics are used to evaluate the model. So finally, we have given some idea about the deep learning. So and where and finally where we are getting the data sources are available and what are the research trends going on. So like that, so far I hope that I completed my presentation in just a little bit level. You hope understand the things. So if you have any doubt, please clarify now itself. Suppose if it is I am not able to clarify also, definitely later I will clarify, or you are through phone or mobile, your mail also you can approach me, no problem. Any feedback about that presentation, my session? Hello, Saravanan sir?
Sir, yes, sir. I'll be there, sir.
Okay, sir.
Participants, if you have any doubt, sir is waiting for
no problem.
clear
Doubts. You later also you mail me, or you my mail number also, my mail ID also given. My mobile number there. I will share all the presentation. I will share the workbook as well as I share the PPT slide to the sir mail ID. Sir will forward the things. Okay. No, there is no doubts. Good.
Sir, I have one doubt, sir. This is
Ask,
Suresh
sir.
Kumar.
Okay.
Sir, in compare with machine learning,